morning, everyone. To the end, good morning. So, welcome to KCD Hyderabad. We have come all the way from Pune to share little knowledge what we have with you. So, myself, Kunal I am co-founder at Stoppage Technologies, and there is Rajani and
So, hi guys, good morning. So, my name is Rajani and I work as a DevOps engineer in an MNC, and in total I do have around 3 years of experience.
Okay, so today we have a very interesting topic. It is about the role of eBPF in Kubernetes. So, how many of you are using Kubernetes in production? Okay, cool. Have you used any eBPF tool or any technology related to eBPF? Okay, let's start. Okay, correct me if I'm wrong, I can't hear. So, before moving on to the eBPF, let's learn about what is BPF, actually why did it came. So, if we go to the history, so it was developed in early 90s because the guys who know about the kernel, the Linux, we have user space, we have kernel space, right? So whenever we want to debug something from network side, so what we have to do is, in the early 90s, we need to copy paste what have been going under the Linux kernel onto the user space. So it was getting very difficult for the analyze what is happening with the network. So we have to filter the packets, we have to monitor the packets, and it was getting a tremendous job for network engineers. So what they did, they came up with a BPF solution. So it was developed in Berkeley labs only. So what they did, they extended the version of Linux kernel with something called BPF. So what they do in the early 90s, they collected that program, put inside the Linux kernel, and have you any of you used TCP dump, right? It gives you what's coming through your ports, right? That is an eBPF program, BPF program. So whenever you use TCP dump, always remember you are using a BPF. So that there were some challenges. So it was assembly level language. So early 90s people were writing assembly level, but me or you guys, we don't know assembly. So in the early 2010s, 2011s, they came up with a solution eBPF. So it was a community-driven project. So what eBPF does, it's a C-level language. Now C-level language is easier than assembly. Okay. So now we have ability to write a code which is human understandable now. For now, we don't know assembly language. So it is human readable now, and that can be converted into native code. So there is JIT and all other things which convert this C-level programming language to the native code that will be understandable by the Linux kernel. So before the architecture, as I said, there is a JIT, just-in-time compiler. What it does, it just compiles the C-level code to the native code. So there is a term called sandbox environments. We all have used it, heard it, right? It uses the same concepts within the clusters. So what it does, it has a sandbox environment, a sandbox program with your processes within your kernel, inside your virtual machines. So it helps us in network interfaces where you want to capture network packets, you want to monitor network and other requests. So this is an example of architecture. So we are going to take an example of Golconda Fort. How many of you visited Golconda? I'm from Pune, I have to visit, but I've heard. So do we have laser? Okay. So we have Linux kernel, and there is this process syscall. This is user space. Okay. So consider yourself as a king and queen of that Golconda Fort now. And we all are workers of it. Okay? So process are the people who are working at Golconda Fort. Then there are syscall. So syscall is something which helps you with day-to-day operations, right? The people are working and there is administration. So the administration tells people what to do, and you as a king or a queen know what is happening behind the scenes. So now, when you come to a fort, so there must be a library, okay? there will be different rooms where there will be things kept. Let's say there is an armory. So armory must have some boxes for guns, for bullets. So let's consider file descriptor as our armory, BFS as the file system, what we call. So there is bullets, okay. Now there is a war going on. So how will you know how many bullets you have consumed? So we have eBPF program over there. So it's like a lamp. It will highlight what's happening inside your armory. How many bullets have been used? How many bullets are left? And what kinds of operation do you need when it goes to the storage, or just now coming to the technical part. So now let's say socket is your what? It's a messenger, right? It sends message from one place to another. So this eBPF system or a program will make sure that the message is going from client to server or server to client in the format which you want. Any questions? This is an important part. Cool. So moving on to the role in Kubernetes. So this was just a Linux level, kernel level thing. Now we move on to the role, how eBPF works in Kubernetes. So I will hand over the mic to Rajani.
Okay, so we'll move forward with the role. What exactly is the role of KDS when we are talking about security and networking? So first is basically networking. So what exactly is eBPF doing here? Like see, we have to process a lot of packets when we are dealing with KDS and eBPF. So the process of packet processing, okay, we can directly integrate it into the kernel level only. So what that's going to do, that's going to enhance the overall efficiency and the speed of packet processing is going to increase because we are directly integrating this into the kernel level only. And next is load balancing. Like eBPF is going to give you the privilege that on the go you'll be having that power to modify the packets basically. So and you can modify the packets on the fly and you can decide how exactly you want your traffic to be diverted from, like you'll be having multiple servers running. So you can make the decision that where exactly you need to divert that traffic to. So here load balancing also is going to be very easy. And next is basically it's going to also help you in service discovery within the Kubernetes clusters. So this was about networking. So next is basically security. Like all the security policies that you want to implement in your packet processing or in the entire process of dealing with KDS and eBPF, like you can integrate these policies again into the kernel level only. So before the process of packet processing is going to start, like all the health checks or any kind of security checks are going to get already performed first. And then you are going to go to the packet processing. So again, it's very helpful when you are considering security aspect. And again, we have network access controls. Like you can decide like which packets are there, which are gonna stay, and which packets are there to which you want to leave the process. So again, that it's providing like access level controls. And next we have observability. Like real-time monitoring, you can do like you can perform multiple logs and you can perform multiple monitoring systems, and you can take a report and you can take the logs and you can use these logs later on if you are finding any kind of issues, or if because of any issue the process is failing, then you can go back to these monitoring reports and you can cross-check the things. So this was about the role. So what are some of the challenges in implementing eBPF-based solutions now? Like first is basically steep learning curve. Like when you are planning to start learning eBPF, the first thing you need to have a very deep knowledge of all the low-level system internals, and you'll have to understand how the networking protocols are working. So and also you'll have to understand the structure of kernel. So the learning curve is very deep here. So that we can consider as one of the challenges. Then we have performance overhead, like the initial compilation time, and again we can say is going to be a little more, so that can add to the overall performance overhead. And also the memory is being used here is going to be directly from the kernel memory, so again this is going to add to the performance overhead too. So next is basically security considerations for eBPF programs. Like you will have to make sure that whatever programs that you are going to written for your eBPF, that is directly going to get integrated into the kernel level. Okay, in your program and you directly went and integrated the same to the kernel level. So that's gonna crash the entire kernel. So you have to be very careful while writing the programs. And last we have is limited documentation. Like eBPF is, we can say in a way it's new in the market and the community is very less. We can say like there are people who are working with eBPF, but considering the community, there are less people who are working in eBPF. So you can find trouble if you are planning to get started with eBPF. So next we have best practices. Like first best practice we can have like you can make sure that you are using the existing frameworks and libraries. Like we have multiple frameworks, like we have BCC, we have eBPF, we have BPF tool. Like by making sure that you are using the latest and existing frameworks, like this is we can consider as one of the best practice. Then we have optimizing eBPF programs for efficiency and minimum performance over it. Like see, whatever programs you are writing, it's always going to be a good practice that you are keeping your code as minimal as possible. Because definitely this is going to reduce a lot of further complexities we can say. So this is a good practice that keeping your code minimal. And then we have implementing security controls and sandboxing. Like again, by sandboxing, you can create an isolated space for your application to run. So this is going to help you to reduce or avoid any kind of security vulnerabilities. So these are the only 3 best practices that I have mentioned here. But apart from these, many more best practices are there. You can definitely go and research around that. Okay, so next we have Cilium. So I'll hand over to Kunal.
So, another question. How many of you are using service meshes just for TLS securing? Nothing else. I'm one of them. So, Cilium is an eBPF tool for sure, but most of the time we use for the things which we do with service meshes. But it just adds a layer on what's happening around the network. So, we'll deep down into the Cilium. So Cilium's best feature that I've always discovered is the network policy thing. We have a demo. They have the best network policy, if not the best, one of the best policies they provide. Whether it's from port to port communication or service to service communication. They have service discovery and load balancing, which every service meshes gives, and other security monitoring tools. So they give 3 different kind of tools. One is the Cilium UI, where you can see the network from client to server or the port-to-port networking, and they have metrics as well. So if you are using Cilium, you don't have to use other tools. Like they have metrics, they have networking. You just have to monitor your logs and you are good to go. So Cilium contribution to the eBPF community is driven by ISOVEN, I guess, a company who is actively working on Cilium. They have made Cilium tool not just a network policy thing. They started with the network, now they are into the service meshes, they are load balancing, they are securing the network, and many use cases. And it is very much easy to integrate with your Kubernetes cluster and easy to use. So what we'll do, we'll go to the demo directly and we'll dive into that. Again, it's a demo. I made some changes sitting over there and it was messed up, but still we will have some files to look at. You will get an understanding how Cilium network policies work. Okay. So we'll go with the manifest first. Very basic manifest. We have Nginx deployment with one pod, one replica is running. We have an Nginx service. We'll deploy it on the Kubernetes cluster. I have Cilium installed for time being. Then we have BusyBox client, where we'll just go into the BusyBox and try to connect to the Nginx service. And we have another pod for unauthorized BusyBox. So one which will be allowed, one which will not be allowed, and a network policy file. So this is an interesting part. So we are just saying to Kubernetes that I'm using Selenium network policy, where you have to allow only BusyBox to the port 80. We have our port name written in our BusyBox file called BusyBox, and we have unauthorized BusyBox which has unauthorized BusyBox. Once we apply these policies into our cluster, so again I'm using lens ID. So let's just delete this. Okay, so we are into the directory. We'll just apply okay. So Nginx is running. If we go to service and port forwarded, it will just run. Hopefully, yeah, it's running. So now, let's apply BusyBox. So I have made aliases, so I don't want to always keep typing kubectl apply -f, so I have just made cap. So now BusyBox is created. So again, to reduce my typing efforts, I have copy-pasted commands. Now we haven't applied any network policy, okay? If you go, it will directly take you to Nginx service. Now it has the access. Even if we go through unauthorized, just copy paste it again. It will still, okay, unauthorized is not applied yet. We are able to get into this. Now I have made some mistakes in the network configuration, so even if after applying the CNCF network policy I am still able to go in, but let's see, live देखने चलता है. This is allow. So I have mentioned here that you should match the label BusyBox. Our pod name is BusyBox. And it should not allow unauthorized access. It does. The interesting part is with the UI. Now you can able to see throughout the namespace what different clients you have, what connections you are having. Network logs are there. What type of network was it? What is the verdict? And some labels. So whenever you go from client to Nginx or Nginx to client, or you have different hops, so CVM gives you this UI. It's not beautiful, but it's a workable UI where you get all the requests down below. You have connections going from client to Nginx, pod to pod connections. It gives little information about your nodes and other namespaces. If you go to node lease, it will take time to run. But you get the idea. Let's just check. So that was it from my side. We had the network policy which denied the connection, but I messed it up. So that was the CVM tool. I hand over to Rajani. She wants to share something.
Okay, so basically this slide belongs to me because I am a technical influencer on LinkedIn. So this is nothing but self-promotion. So if you have any doubts, either you can connect with me or Kunal. So these two scanners you can scan, and you guys can connect with us on LinkedIn or any other social media platform that you're looking forward to. So that was the session from our side, guys. So I hope you got at least some insights like what exactly we tried to sum up here. So thank you.
Kunal and Rajani coming all the way from Pune for Hyderabad folks. Anant, I would request you to give a small token of appreciation to Kunal and Rajani. A round of applause, please. So before we pivot into our next session, I just want to reiterate what we talked